Hello, today we will explore the world of junction transistor or UJT. We will see how it works, why it's so special, and what makes it important in the world of electronics. So what's exactly a UJT? Unlike other transistors, a UJT consists of one p-n junction and three terminals, B1, B2 the bases, and one emitter. You can think about it as a gatekeeper that controls the flow of the current. The two bases are connected to the end of the N bar and act as a resistor. So we can replace the UJT as the circuit shown here.
The intrinsic standoff ratio eta, which is an important parameter in a UJT, is equal to RB1 over RBB, the sum of RB1 and RB2. Applying a voltage supply of VBB now, the voltage across RB1 is easily calculated to be eta times VBB, which is through simple voltage division. Now, knowing the intrinsic standoff ratio firstly and adding up the voltage at RB1 with V, we come up to a key parameter Vp, the firing voltage, which is expressed by the formula on the slide. Accordingly, if the emitter voltage VEE is less than Vp, this means that the UJT is happily turned on. Otherwise, if VEE is greater than Vp, then the diode in the circuit shown on the slide is off and the UJT is consequently off. Now we are going to dig into the VI characteristics of a UJT. As you can see, the region to the left of the V peak is called the cutoff region, where the UJT would be off, since the voltage at the cathode terminal in the case of the diode is eta times VBB, and supply voltage is less than that. Here, the diode would be reverse biased. However, at V peak, the UJT would be on. Also, the region where the value of the voltage decreases is called the negative resistance region, since as voltage decreases from V peak to V valley, current increases from I peak to I valley in an opposite manner. Lastly, the next region is the saturation region, where the emitter voltage remains approximately constant, however, current remains increasing.
By pairing a UJT with a capacitor, we can produce what is called a relaxation oscillator circuit. This circuit is used in creating repetitive, non-sinusoidal waves such as ramp waves, square waves, or sawtooth waves. A common use of this circuit is in time-based circuits, such as strobing flashlights, turn signals, or signal generators for oscilloscopes. UJTs are also used in triggering SCRs and triacs in phase-controlled and dimmer circuits. Some advantages of UJT include low power consumption, high trigger sensitivity, and cost effectiveness. In addition to that, they are very reliable and have a long lifespan. Meanwhile, some disadvantages include having low current and voltage rating and high temperature sensitivity. In addition to that, they have slow switching speeds compared to new semiconductors. So in conclusion, a UJT is a three-terminal device used primarily in triggering, timing, and oscillator circuits. It has a single p-n junction and is known for simplicity and reliability.